Okay, good evening, everyone. We'll get started in just a moment. I just logged out of Blackboard, huge mistake when I click out, and now I'm gonna have to relog back in. And I don't know, for some reason it bothers me how much it asks, but like all the fact, I get it's secure, but it bothers me. Okay. All right, so hopefully I posted everything, all of the class notes last time. I'm hoping I did, and I do know that I posted the review and the answer key. And first, I just want to say that okay, so sorry, Victoria, it is just review today, and I'm going to go over your quiz as well. Yeah, so to answer that question, but I just want to say that the review has like 30 problems or more on it. The test is 11 questions, and some parts have like ABC or AB, but the test is not long. Like the review is made to give you way more to study. One, in case you have the time, and two, maybe do one or two problems from each section. Yeah, the review is also optional. I mean, you do not, and well, so class tonight, I will mark attendance. So like it does count as an absence if you're not going to be here. I can, after I go over the quiz, maybe I'll do the question of the day then. And then if you guys do want to leave and don't want to be here for the review, that's fine. And I can mark you present if you're here for just going over the quiz. But I mean, I picked 7 questions on the review that are almost identical to 7 questions on the test. So if if you have that 7 out of 11, that's already a pretty good, pretty good kickstart to your test. Keep in mind that on Thursday, you will need a camera to be on. And I have not heard from anyone about this being an issue. So just keep in mind that on Thursday, maybe practice it Wednesday. Yeah. If you want, but yeah, you will need to have either a camera on your phone or on your computer. And again, don't just have it be your face super close up, even though that'd be great to see you the whole time, but have it be a little bit more of your space, or if you're sitting, maybe just focus it on your paper, but not close enough so that every student can see all of your answers. If someone is sitting there just watching someone else's answers and copying that, I would be kind of impressed, but that also sounds like horrible. And yeah, if you have difficulty with the review, feel free to send me an email, but also ask questions tonight. So I'm going to go over your quiz, and then I'm going to do those 7 review problems, and then we are going to open it up for questions. So however much time is left. Do you ever print off or you looking at online printer? Yeah. So okay. So Miranda's asking about the test. The test is going to be in a PDF online, so it will open up when class start. Like I will open it when everyone's here, when class starts. I will also be recording the meeting, make sure everyone has their camera on, all of that. And then, so you have the option to either download the PDF, and those of you that have access to write kind of like a tablet, like I have, if you want to write directly on the tablet, go for it, save it, submit it, right? If you do not have access and you normally print your notes, I'm very sorry, but you'll just have to write it on your own paper. So have some paper ready. If you have a printer like in your room with you and you can literally print it right there and it won't waste time, go for it, print it out, write on it, and submit that. But I don't recommend that just because like, what if it wastes time and then you're printing and then you're not like, that's maybe not the best way. But just show your work as best as you can on a regular piece of paper. Veronica saying, for some reason, my audio keeps going out and I can't hear you. I keep logging in and out to see if it helps. Any suggestions? Can everyone else hear me clearly tonight?
Yeah, pretty good.
Okay, so Veronica, this could be.
I had that problem.
You had that problem as well? Maybe turn your video off if you have video on. Okay. So look at computer screen to see test problems. You're joining with computer audio. Yeah. So sorry, Veronica, sorry, I don't have great advice. But if other people do, feel free to type in the chat for her. Let me type in, or let me share my screen and I'll write this. I'll write this out, what I'm kind of saying about the test. So if I can figure this out, share my screen. Yeah, okay. And we're trying to get it sideways, and we're gonna, okay, so we're gonna review, but maybe before I do this, test, oh my goodness, oh, okay. Oh, wow, it won't let me, that was weird. Okay, so it like won't let me write where I had text, but that's fine. So test, let's see, it will open in Blackboard at the start of class. You know, write your answers on paper or directly on the PDF. Then you'll submit. Actually, and maybe the order of this, so you'll write your answers out, and you can, I mean, you can skip around and solve the problem. Oh, somebody said, sorry, I'm just pulling up the chat. I don't know how to turn on closed captioning. Do I do that? Yeah, I have like zero clue how to do that.
There's live closed caption.
Let's see, view options. Yeah, I don't think I have access to do that, or I don't know if you can do that. Yeah, maybe you can do that. Oh, faculty closed captioning. All right, there's an article. So I have to enable it. Yeah, okay, well, I can only, oh, I have to enable, I see. Okay, maybe let me, I don't know if it's gonna work though, if for some reason I don't have this enabled. I don't know. Let me just go to settings and see if I can select it, and then if that changes for you during this meeting. If it doesn't, I'm sorry. And let's see.
Oh.
Yeah, audio type, I don't really see, I see the link you sent, but I don't see this like option for me in my Zoom. And I don't know if it's because I can't find it or I have to be off of Zoom.
It's
Right.
okay. I'll do later.
Yeah, for next class, I can look at that though. And, you know, I can go to that link and try to do that.
Yeah, sounds good.
But yeah, this is, because then if there's any audio issues, you can just. Oh, it actually said, okay, well, this is interesting. I'm seeing one, it says that I'm seeing one option to share closed captioning, and it says ACC has disabled this option for me. So I will still look into that, but I don't know if that means they don't let me do it. So that's a bit weird. Okay. Let's go back to this. Yeah, God, we love college, right? Okay. Okay, let me
recording in progress.
Continue recording this. So it will open in Blackboard at the start of class. You write your answers on paper or directly on PDF with, oh, I'm still on eraser here, with camera on. What was the next thing? Oh, when finished, you will type done in the chat, in the Zoom chat, then submit your work on Blackboard, right? So what this does too, it allows me to see, okay, if you finished at 7:15, but you didn't submit until 7:45, either something was horribly wrong with your connection or something happened, right? Or that's suspicious and that would be investigated and as cheating, and you just don't want that, right? So you have a small window. I mean, realistically, 5 minutes. If you have major issues and you're messaging me like this still isn't working, maybe 10 minutes, but you should only have this few minutes after you message done to then make a PDF, like scan your submission in, right? Or save it and upload it, whatever you need to do. So you all at this point know how to upload, a submission because we practiced on those quizzes. So hopefully this is not, an issue, but this is how it will be for the test. Now, I do want to go over your quiz first. So let me find that. This was the review. Trig quiz. No, is that it? Maybe. No, that's not it. No, all right, ignore that. Files. Okay, maybe it was on my iPod. Oh yeah, here we go. So so this is the trig quiz. And maybe I should. I wrote the answers out. If people want to see the work again, I can do this, but I just wanted to share the answers with you because there were some mistakes made, but most people did this and did a great job. And I also accepted different answers. So if you got 100 or whatever, and you say, mine looked a little different, well, there might be a reason for that. So just looking at this, number one, we convert degrees to radians. This isn't even on the test, the converting, right? I mean, if you need to convert, sure, but this is not a question on the test. But these were pretty straightforward, I think. And if you made a mistake, it could have just been a simplifying thing. Then for problem 3, we had find all 6 trig functions for this triangle here. So you had to do, I didn't write it out. I don't know why, but you had to do like 11 squared plus 13 squared equals c squared. You had to do Pythagorean theorem. And you got 290 equals c squared. So this side was the square root of 290. A few of you made that a decimal. That's fine. I preferred not a decimal. And if there were, but I accepted the decimal because I did not say this is my fault. So I accepted the decimal. I also accepted, there were a few people that just left it like this. Okay, on a quiz, I'm not so concerned about rationalizing. I made a note there saying like, hey, make sure you rationalize, but I wouldn't worry about it. And because this was a bit tricky because it wasn't some nice clean number. And so from there, your angle was here and you just had to remember SOHCAHTOA. And then these 3 here just flipped each of those fractions, right? So I'll kind of let you look at that a moment. Any questions on 1, 2, or 3 before I kind of continue? And I guess I should have the chat up. I see no. Okay, good. And I should have graded them all. If for some reason I didn't, let me know, I guess, or send me a message. But I think I was able to grade them all, and I think I was able to read everyone's. If I didn't, I wrote you a message, and hopefully we resolved it. Because I think there were 1 or 2 people where they had to submit again because I couldn't see it or something. Okay. All right. Sorry, I'm scrolling through to make sure. Okay. Okay. So let's keep going. So then number 4 was this tree cast the shadow. The elevation was 49 degrees. Find the height of the tree. So for this one, and again, you are allowed a scientific or graphing calculator for the test. So in this case, you definitely would use like a calculator. And I accepted all answers like 87, 87.4, 87.42 or 43. Like I accepted all of these because again, I didn't say. If you were slightly off or tried something else, there should be a note to you. And you should be able to see, something like a little note that, oh, hey, I see you tried this, but like what you should have done was this or something. Yeah. Okay, and then for problem 5, we have Alonzo flying a kite. And so I did have one question, I think, is somewhere that we're assuming, we're assuming this is a straight line. Like, I know this looks like curved, but okay, we're assuming that was straight, not curved. I think they're just, this picture was just maybe a little realistic, that the string isn't necessarily perfectly straight, but maybe it was extra windy. But so the only mistake I saw in this one, or the biggest, was, you'd set up your SOHCAHTOA with your right triangle right here, right? And you'd set this up. But then when you solve, make sure you're in degree mode, and you would get, some people said like 10.4, 10.39, whatever. But you have to add this 1.65 back in, because we're asking how high the kite is flying above the ground. If it was above his hand, then that might be, you could, like, maybe he's holding it, like you see here, like above his head at his height, but we're assuming this distance here as well. So, and we didn't really go through that, I think, in class, so that maybe was a little tricky too, but you just had to add the 1.65 back, and it was about 12 meters or 12.05, 04, depending on how you round it. And the last part of this is going to be the unit circle. So for this one, I know that I gave you the unit circle here, but on the test, I'm not going to be able to give you that. And so, I would recommend that you try your best to have, like, just to know it and study it. You don't need to necessarily know these, like these you do not need to know, but the way to find these types of angles, and I didn't really show my work here, but it's to think about, okay, what is the reference angle to this? So for example, for -7 pi over 3, well, I know that, in radians, -7 pi over 3 is close to, so -6 pi over 3 equals -2 pi, right? So if I started at 0 and negative is going this way, if I go all the way around, that's -2 pi, which is -6 pi over 3. Then I have one more pi over 3 to go. So then if I kept going to here, this would be -7 pi over 3, right? And then I could think, okay, I know I'm in this quadrant, I want cosine. Well, X is still positive. Like, this is X and this was Y, right? So for my point, X is still positive. So I know it's going to be positive. And then, and I haven't even thought about what is it yet, right? But I know that my reference angle for this, if I add 2 pi to this angle, my reference angle is pi over 3. So like, if I was to draw this angle here, and I know it's all the way around. Oop, I went the wrong way. Sorry. It's all the way around and then back here. So the reference angle is this right here. And I know that that's pi over 3. It's negative pi over 3, but it doesn't really matter, right? So it's pi over 3. So if you have that first quadrant memorized, I just figured out where the angle was. So if it's positive or negative, and then I don't even have to worry about the sign. I just think pi over 3. Okay, pi over 3, what's sine and cosine? Well, cosine's 1/2, sine is √3 over 2. So if you know those things, and even if you want on your test, if you want to just write out, and I just like butchered this whole little chart here, but if you want to write on your test, like as soon as you get it, like just this quadrant, and like write out what these are, it could help you. You can totally do that. That's not cheating if you just write it out as soon as you get the test, because you can use that. But this is something that I'm not going to be able to give you. And the other thing, which I will talk about when I do the review, that I won't give you is which functions are even and odd. So to remember, like, the even functions like that for the even functions, like if you subtract 2 pi, they're actually the same thing, or for the odd functions, if you subtract pi, they're the same thing, or what, this type of thing. We're going to look at this today and do an example, but that is also on there, just one of the problems. And so you'll have to know that, because I'm not going to tell you like, oh, remember, I mean, there's only 2 even functions. So if you can remember that, the rest are odd. And so you should hopefully be able to work from there. But anyway, so the answers to this, like I didn't even go over the answers. The answers were 1/2. Then, I think I messed this up. I think this is positive root 3. You can correct me if that's wrong, but I know I graded it right, but I'm looking at this now. I think it was just positive root 3.
Mhm.
Yeah. Okay. And then, so some people did put 1/0, or they even left it like 1/sine 5 pi, which, okay, yes, you're right, but you need to tell me that that's undefined. I want you to know, but I also want me to know that this is undefined, right? So we wouldn't say 1/0, that's the great answer. And then for sine of negative pi/4, it's negative root 2/2. So those were the answers there. And I think that was it, right? Yeah. Okay. So any questions? Oh, I'm going to pull up. I'm so sorry. I'm like, I was prepared for class, and now everything on my computer closed, and I'm like, wait, where's all my documents? Okay. Okay. If there's no quiz questions though, I am going to just give the question of the day. Oh yeah, somebody did ask a question, so I'll answer this, and then I am just going to give the question of the day, and then I'll let, like, again, those of you that want to leave, okay, you can leave, and those of you that want to stay for the review, you can stay, right? But the question I got was, Victoria's saying, is there still a group me? There for sure is. So if someone wants to share that, yeah. Okay, so I did get a question though about problem 3 and how did I find that hypotenuse? So you just might have missed that. So to find, how do I want to like get rid of this, but okay. So to find the hypotenuse, I used Pythagorean theorem. Whoa, if I can spell. Pythagorean theorem, which is a squared plus b squared equals c squared, right? And then I kind of wrote this out. So I did this right here. And hopefully that helped. And thanks for sending the group me. But that's how, so one side, the other side, you can solve using Pythagorean theorem, right? Okay, yeah, cool. That answered the question. Very good. And today it's going to be the question for today. I mean, last time you gave me books and movies to read and watch and write or whatever. Today you're going to give me your favorite, or at least one of your favorites. I get if you can't pick. Restaurant or food. Okay, so favorite restaurant or food, and preferably in Austin, because hopefully we're all here, or I'm here and I like to eat. So if I haven't tried it, I'd love to. But yeah, so and you can wait if you don't know yet, and you can answer later. But yeah, so tell me like your favorite food to eat, or a favorite restaurant, or even a dish from a favorite restaurant if you want to get super specific. And if it's local to Austin, that's great. If not, I mean, maybe I've also had it, like Dairy Queen, I've for sure had. Oh my God, Casa Colombia, so good. Yeah, so all of these, this now, I mean, I just ate, so luckily, hopefully I don't get hungry just from reading your answers. But yeah, so thank you for that. And again, if you'd like to just head out, I'm not super offended, only slightly offended. No, just kidding. Okay. Now I was looking for something, but okay, so oh, I'm looking for the review, but I need to do it on my iPad. So let's go here.
You said the test was open book, right?
No, the test is not open book. No.
Oh, shoot.
The quiz was open book, right? Yeah, the test is not. So, and you will need your camera on in your test. You won't be able to use any notes or anything like that for the test. No. Okay. Let me figure out reviews. Is this, or is it on my iPad? All right, sorry, give me a moment to figure this out because I don't know where, or maybe I'm just gonna open it on here. Yeah, maybe I'm just gonna open it. Reviews, review, careful, I wanna click, all right, let's see. Okay, so like I said, test has 11 questions. I think I tried to do 12, but then I ended up having like the last one is ABC or ABCD, and I was like, no. With, I'll just say with multiple parts. And this, I'm telling you this so that you're not stressed out. The review is very long, for those of you that didn't hear this. And, you know, I don't want to stress you out. Now I'm going to pick like 1 or 2 problems from each of these kind of sections, and we're going to go through them. The reason I'm picking them is because they are, or something like it is on your test, right? So, so this is why we're doing it. Now, what I really should have done is told you guys which problems and then had you do them or talk me through them. But maybe I will have people who have looked at the review or started. Maybe it will also help if I kind of let you try to talk me through it, or maybe what is the first step that you did, something like this, right? So right off the bat, we see some word problems. You're going to see that on your test, but again, don't be intimidated. I think I was telling someone in office hours, if you hate word problems and you're like, they're so hard, when you get the test, skip all of them, do all the trig questions, and then go back to the word problems. You're going to have time. And if that puts you at ease, that's fine. Just make sure when you submit, you know, try to, if you're going to write it on paper or something, maybe have one side of a page for each question so that, or maybe a half a page or something, so that when you do it, it's not like, oh, problem 7, then 9, then 4, that, you know, like, because grading will kind of be a nightmare. But I mean, I guess if you do that, that's out of my control. So let's start. We're going to start with number 2. And I don't know if I'll have room. I know there's not really room on this review. So if I need more space, I'll go to I think did I leave this up? Yeah, I'll go here. And these are the questions that I had picked. Okay. Okay. So for this one, it's a book question, right? 5-1-113. I think that's what that means. I should know. So 2 gears are calibrated so that the smaller gear drives the larger gear. So as this gear rotates, it's connected to this, so it's rotating this gear as well, right? And for each rotation of the smaller gear, how many degrees will the larger gear rotate? And it gives a hint. It says the arc length traced out by the touching gears is the same for both. So the arc length of this is going to be the same as the arc length that goes around the bigger one. So what that means, just like in my head and how I'm seeing this, which maybe helps how you see this, is that for one full revolution of this, right, which is 2 pi. So, oh wait, actually it's not just 2 pi. The radius is 2 centimeters. My bad. What's happening? So one full revolution of this, say it was 2 pi. Okay, say we went 2 pi in our what is this called? Degrees. Say we went 2 pi degrees, one full circle. Then this would also go 2 pi, but maybe because it's bigger, maybe it's only actually this much, right? I mean, something like that. That's what's going on. And what we want to figure out here is what is that arc length, and then how does that relate to the bigger gear? So okay, so
you're looking for the arc length of the bigger gear.
Well, we're looking for the arc length on the like how many degrees of the bigger gear it moves, But we want to find the arc length of one total rotation for the smaller. And it's going to equal the same on the bigger, but then we have to find an angle because we know, so like say I start, and maybe I'll switch my color. So say I start at this point. Oh, and yellow was crap, right? So say I start at this point, right? And I do one full rotation, right?
Right.
On this, if I started at this point here, that is not that one full rotation. It might stop me here because the bigger gear is not going to go all the way around because that when the smaller gear goes, right? So the arc lengths will be equal. Like this arc length would be equal to whatever the length is of one full circle there. And then we want to figure out, okay, what is this angle? Like the angle I drew is almost 180, right? Which, okay, that's not going to be the answer, but it's something like that. We want to figure out what is this angle. And we know that what is the arc length? S equals R theta. So we know S equals R theta, so we'll use that. So for the first one, to figure out the arc length, we're saying for each rotation of the smaller gear, so one rotation is, I'm going to do this in radians, or oh shoot, is the answer in radians or degrees? Oh, it says degrees. It says degrees. My bad. Okay, we got to do degrees. So all you degree people, you're welcome. I don't remember if it's degrees on the test. It probably is because it looks just like this problem. Oh, and for the person who just messaged me, no worries. If you can log back in when you're home, that's fine. But yeah, thank you for letting me know. So I have, I was going to say it's 2 pi, but it's actually 360, right? Is 360 degrees. So the arc length, so S of this little guy, S is going to be radius 2 centimeters times 360 degrees, which is, oh gosh, 720? No, 7, that's 720, right? So and it's not degrees. It's just 720 is my arc length. So this is my arc length for my little guy. So now, and so this is my S, right? So now I take this S, 720, sorry that's probably really hard to read, 720, I substitute it in here, but then I get the 5 centimeters as my R, and I solve for this. Okay? So hopefully people are with me. I should have asked more questions, but okay. So now I'm going to say 720 equals 5 times theta, right? And now I divide by 5, and hopefully this works. Theta equals. Okay. I don't actually, what is this? 124, right?
144.
Oh, 144. My bad. Okay. Thank you. Okay. So 144 degrees. I was trying to divide that in my head, and how pathetic. Okay. Been a long day. Obviously, I said it was, I don't know if I said it in class or office hours, but it is Tuesday. And to me, it feels like 3 weeks have gone by since yesterday. So, you get it, right? So 144 degrees is my angle, and that is what we were looking for. So what this is telling us, which I actually kind of drew it accurately by, some gods are with me or something. So when this moves around one whole 360 degrees, this gear actually only moves 144 degrees because the radius is bigger, which no big deal. And again, don't be intimidated. This is, here, wait, we'll
Recording
pause the
stopped.
recording. This is on the test, okay? So something like this. So just you got this, Okay.
Recording in progress.
All right, what did I say? Number 3, I think I said next. So let me venture on to number 3. Okay, so now we have a circular paddle wheel of radius 3 feet. And for this, I don't know what a paddle wheel is, but I think, maybe it helps to draw it out. But 3 feet is lowered into a flowing river. Okay, that's a wheel, and we can pretend it's a wheel, and it's being lowered into a river. Oh, well, maybe I'll do it. This picture is not going to help, but okay. the current causes the wheel to rotate. So these waves that are coming in are making the wheel turn, right? One way or another. And the current, it causes the wheel to rotate at a speed of 12 RPM. So our speed is 12 RPM. Okay, rotations per minute. I believe that's what those. So to 1 decimal place, what is the angular speed in radians per minute? Oh, it's radians per minute, not rotations, my bad. So what is the angular speed? Find the speed in feet per minute, and then find the speed in miles per hour. Okay, so what we want to do here, and again, this is similar to, I think, something in 5.1, or at least so it says, right? Yes, right.
B and C are looking for linear speed, right?
Sorry, say this again. What's up?
B and C are looking for linear speed.
Find the speed.
Linear.
I'm assuming, right? We haven't done anything else, right?
Right. Well, you got angular speed on A, and then.
Then I
you're
see what you're
looking at
saying.
B.
Yeah. So they should have said linear in here, but let's assume that is true. I see what you're saying. Yes.
Right.
Yeah. So let's assume, that is linear speed. Okay. So for part A, we want angular speed. Remember, there's these equations. Now, I'm so torn because I'm realizing now you do have to use equations here. And I don't know if I should have, I don't know if they're hard to remember, but maybe on the test, if somebody asks, maybe I'll type it in the chat, or maybe if they're like, what is the angular equation again? But I'm just going to write it here, that angular speed is this weird omega or W, right? And then we have, it's the angle divided by the time, right? So in this case, we have, I'm sorry, my dog is chewing stuff that he's not supposed to, so I'm just gonna lose my mind. Okay. So we have 12, we have a speed of 12 revolutions per minute, circular paddle, radius is 3 feet. So what we wanna do here is get our angular speed. Why am I not doing this? Okay. Oh, in radians per minute. Did they give us? That's because this is 2 pi. Okay. So our speed is 12, but we want to get, we're already per minute, so we don't have to, sorry, I'm thinking we need to get this per second, which we would have to divide by 60, right? But we're already per minute, so forget the dividing by 60. So the time is already like 1 minute. So we have that 12 revolutions every 1 minute, 12 over 1. So that's all set, right? Then we have, all we want to do is multiply this by 1 revolution. So what is 1 revolution in radians? It's 2 pi. So this is 2 pi. Because that's going to be our, that's going to be how we convert it to radians, right? We multiply by the 2 pi. So here we just get, this is so much simpler than I'm thinking. I don't know why, but we just get 24 pi, right? This should be 24 pi radians per minute. And the 2 pi is 1 radian for 1 revolution, but we're doing 12 revolutions in a minute. That's why I'm multiplying 12 by 2 pi, right? If we were doing 300 revolutions a minute, it would be a 300. If we were doing 1 revolution, it would just be 1, right? Okay. Okay. So this was A, and hopefully that's correct. If anyone disagrees, or if I do something wrong, or add or subtract or multiply wrong, please just stop me. Clearly today is just too long of a day. Okay, so B is find the speed. This is where Michael was talking about linear speed. So we're going to be using that linear formula, which let me just write it on the side. Linear speed is V equals, it's V equals S over T, which is also R theta over T, which is also, so maybe I'll write them all. S over T, R theta over T, or it's also just R times omega.
Yeah.
And we just found omega, right? So the reason I wrote them all, and again, maybe I'll just type these all in the chat on Thursday. If I'm, feeling, cause like, it's really not important that you have these formulas memorized. It's important that you know how to use them. Right. So here we can just use, we want in feet per minute. So we can just use the radius, and it's already in feet. So no converting, which is good. And then we have V is going to be 3 feet times 24 pi. This is omega, right? Times 24 pi radians per minute. And then this will get us a speed of, okay, we don't ever write radians out usually, right? So this will get us a speed of feet per minute. And it'll be 72 pi feet per minute. And that's the speed of the current. Okay, now it wants us.
Matt just mentioned that it does say to 1 decimal place. So should we be converting?
Oh, you're 100%. Okay, so this is so important, and thank you, because on your test, it will be this way. And I just don't have a calculator with me, which is horrible. But now, well, I do, I just didn't have it. So now this is really good. Let's multiply this 72 pi. So multiply that out on a calculator. And I would say follow this now so you know how to round correctly. And this would be 226 point. Now I get it's like 19467, blah, 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 right? Well, it says to one decimal place. So
Right.
0.2, that's it. And then it's feet per minute, right? Okay, and then it wants us to find these in miles per hour. Well, we found feet per minute. Oh, did we? Okay, so I'm not going to make you, this is just conversion. I don't think, now I'll have to check this. I'm not going to make you memorize this. But, okay, and somebody did ask.
Our textbook,
Yeah, what's up?
our textbook use a conversion here.
Yeah, so, and they use feet to miles and then minutes to
yeah.
hours, right?
Like many different conversion, and I don't know how can I remember that 1 mile. Is
Yeah, you will not.
5280.
You will not. Okay, so you will not have to remember this. I will either type it in the chat, actually, you know what? At the beginning of the test, I'll ask everybody. I'll type it in the chat, but I'll ask everybody to write it down. So if wherever you're writing your work on your test, and on the test, there's going to be a blank first page. So, well, it just is for your name, right? But if I want everybody, I'll tell them, and I'm going to make a note of this now for myself. Let's do, so for the test, everyone write, I type in chat. This, I know this might seem silly that I'm writing this out, but I will forget, and that's not fair. So the formulas that I'll write here are going to be, I won't say what it is, but I'll write angular speed. So omega is theta over t, linear speed, which is s over t, r theta over t, r omega, right? I'll write something like that. And then if you need the conversion, so I might have taken part C out on the test and just done A and B so that you don't have to convert. But if you need a conversion, like in this case, 1 mile is, oh my God, I don't even know. So I'm going to have to look it up. How many feet is it?
5280.
Okay, 5280. I should even know that. I feel like all I think of is minutes, 500, what's that famous, you know what I'm talking about, song and play, and 525,600 minutes. What is this?
I don't know.
Rent. Oh my God, you don't know Rent?
Okay.
Oh my God, am I outdated? Okay. Okay, so if you know Rent, the Broadway show or the movie or whatever, they've probably made it into everything now. There's that song, and it's however many minutes, something about something, but it's not miles. So Anyway, I should just know this, basically. That's what I was getting at. And I was Googling it, so you're not going to get it. Okay, so if you need a conversion like this, I will give it to you. What I will not give you, though, is the fact that 60 minutes is 1 hour. I will not give you that. You might need that. Like in this case, we need it. Not going to give it to you. So sorry, but I'm hoping you can figure that out. Okay. So, and hopefully, who was it that asked? Miranda, those are like, I will take the test again tonight, or maybe tomorrow morning. So my brain is not mush. But I will retake it. And if there are other formulas you need, like something like this or this, I will retake it and I will double check, and I will do this at the beginning of the test and just have you all write it. The only thing I'm saying that you do need to memorize is that unit circle, right? That first, at least the main angles, right? So, okay. And then, who else? Or Jakob, hopefully that answered your question, because you were like, how am I going to know what to do here? So hopefully that helped. Okay.
Okay, but
Yeah.
I'm confused a little bit. So
Okay. What's
without writing the 1 divided by 5,280, the answer will be wrong.
because we're not done. You also have to convert it from minutes to hours.
Okay.
that make sense?
I did still.
So you should get, and I would start with 72 pi. So I would start with 72 pi. And then I would say, because that's the speed, but that's feet per minute. So then I want hour. I'm going to start with the easier one. I want hours in the bottom. So I know 60 minutes is in 1 hour. Then I want, instead of feet, I want miles in the top. So 5,280 feet is 1 mile. And then let's hope, is that better?
That's the answer, but I don't know how to remember 5,280. Okay.
No. I'm telling you, Jakob, I'm telling you that if you need that, I'm going to type this at the beginning of the test. I will put it in the chat and you can write it on the piece of paper that you have or wherever. Does that?
Great.
Okay.
Yeah.
Does that make sense?
It works.
Yeah. Because okay, first of all, for most of you that if you are not used to the whole feet and inches or whatever we do here instead of centimeters and meters, that's one thing, but I don't even know the conversion. So that's, and I should, because I teach this and I've gone through it a lot. Right. So actually, I will give you this.
The book also explained how to use the conversion in TI-84. I didn't even know the feature. My calculator have it, but I found the feature is very difficult. Like it is.
Yeah. I would not do not worry about this. So yeah, you will do this just in your calculator, regular. I'm going to put this all in my calculator right now just to check. So what I recommend in your calculator, just do 72 pi times 60. So I'll do times 60 and then divided by, hold on. This is not good. Then divided by 5,280, right? And I'm going to put this in my calculator and I got 2.57. And again, I got 2.57, but it says to round to 1 decimal place. So we'll say 2.6 miles per hour. Right. And then this was the feet per minute, right? So yeah, so hopefully that cleared up any of those. And again, if you're stressed out, if you want to get the word problems out of the way, do all the word problems on the test and then keep going. If you're stressed out by them and you don't want to think about them, you want to do everything else first, do everything else first. This is perfectly fine. Okay. Okay. So now we're going to skip ahead. I don't know if we're taking a break from word problems, but we're going to skip ahead to number 7. And again, I'm picking problems that are really similar to your test. So just keep that in mind. If you think, oh, you skipped number 4, there's maybe there's one like it on the test, but probably not. Right. Now I am skipping a few that maybe you'll see on the test and I can mention it if I think of it. But looking at number 7, we're given this angle T, -7 pi over 4. And we want to do these things, A, B, C. And look, this is really long. I'll tell you now on the test, it's not A, B, C, E, but it might be like A, B, C or A, B, C, D. And it might have just a few of these things. But so let's take a look. So the first one is going to be draw. And I totally get, you know, if your drawing is a little rough, this is okay. Do the best that you can and make it as clear as possible for me. And you're going to be good. So I know that this is 0. This is negative pi over 2, negative pi, negative 3 pi over 2. And you don't have to label it like this, but negative 2 pi. And this is going, right, I'm going this way, right? So I want negative 7 pi over 4. Just for my peace of mind, I want to think, what is this? What is this? Well, I know negative pi is like negative 4 pi over 4, right? This is the same thing as negative 6 pi over 4. Ooh, so negative 7 pi over 4 should be like somewhere here, right? Because if I'm going in the negative direction, it should be there. And it's not 2 pi. Negative 2 pi is negative 8 pi over 4. So it's between negative 6 pi over 4 and negative 8 pi over 4, right? It's between these two things. And so I know that the angle is going to be this, and then it's going to go to here. And again, if your line, if this is not perfect, if you draw something and it's like here or here, as long as it is in the correct quadrant, as long as it is in this quadrant, I'm not going to be too upset about it, right? I'm not going to be picky. I might make a little comment, but I'm going to give you, you know, the points, right? So make sure it's there. And this is going to be, that is our T. I'll label it. This is our T, right? And there you go. And then, I mean, and here would be a point if there was on the unit circle. Now indicate the reference angle. So this is part A, right? This is A. Now part B, indicate the reference angle theta prime. That reference angle is the angle that is closest to the x-axis. So looking at like the x-axis, right? It's the angle closest to that, to your terminal side, which the terminal side is this guy here. So it's this angle right here. And I know that that angle is going to be pi over 4, right? Because this is, if this is negative 7 pi over 4, it's just pi over 4 away from going full circle. And so, and remember the pi over 4, they're the nice ones, and they like are in between every, you know, okay, I'm not going to keep that there, but they're halfway between every quadrant. So, so to answer this, this is pi over 4, right? My reference angle. Then to look at part C, identify the point on the circle. This is where memorizing your unit circle really comes in handy. If you remember your unit circle, this point P, we'll call it P. P is going to equal root 2 over 2, comma root 2 over 2. This is the point. And I just know this because I've memorized the unit circle, right? There's not really a fancy way, but if you were really stuck and you wanted to think about the unit circle, you could try, you know, to like draw a right triangle and label, like this would be 1, this would be 1, this would be square root of 2. And then, you know, you'd have to divide them all by 2 to figure this out. But that, I mean, I think that's more complicated. So if you can just remember the unit circle, it's going to be a little bit easier for you. But yeah, I think that's, and it stays positive. Now, let's say your angle was over here. It just means that the X is negative, the Y is positive. It just changes the sign, right? So remember that. That's also good to remember what's positive and what's negative in which quadrant. Okay, let's move on. Part D, evaluate sine, tangent, and secant functions of T. Okay, they're not saying sine, cosine, tangent, right? They're asking some different things. So this is part D. Sine of T is going to be this, don't overthink this part, right? This is your X, this is your Y, and just remember that sine is the Y. So it's root 2 over 2, okay? Oh, sorry. Yeah, so this means chapter 5, section 4, problem 23. These are all from your textbook, these problems. the review problems, because the course is designed via the textbook, right? Yeah, so that's what that means. So Joseph, hopefully, and Jakob, thanks for answering that question. Yeah. And if you want more like this, go to that section, do all the questions around it, right? I mean, yeah, that would be good practice. Then we got tangent of t. Remember, this is sine over cosine, which is really root 2 over 2 over root 2 over 2. So this is really nice because it's just 1. Then we have secant. Okay, secant is 1 over cosine. And you should also know these types of things, like SOHCAHTOA. You should know that secant is the opposite of, or the reciprocal of of cosine. Cosecant is the reciprocal of sine. So you should just know cotangent, reciprocal of tangent, right? I won't tell you those types of things. You will have to have that, I guess, memorized, right? Okay, so secant. So this means it's 1 over square root 2 over 2. Or you could know that cosine is root 2 over 2 and just flip it, right? You could just flip it. So this is really going to be 2 over square root of 2. And if we rationalize, so root 2 over root 2, this is actually, well, it's going to be 2 root 2 over 2, which now I'm saying so many 2s, it kind of seems crazy, but it's really just square root of 2. How do I erase? It's really just square root of 2. And if you think about it, like we rationalized root 2 over 2, and it started out as 1 divided by square root 2. So when I do the reciprocal, I should just get square root 2 for secant. Okay, now I will say that there are, or is a question potentially, not saying exactly, like numbers, not, like 8, 9, and 10. I'm not saying all 3 of these, but there's maybe a combination of these types of questions on your test. But again, not all 3 of them. But because they're just more trig, I'm just gonna, I'm gonna skip it. But I will say that some of these, like for example, cotangent of 690, that's a lot harder than a question on your test. The ones on your test are going to be angles that you should know a little bit better. They're not going to be like 690 is just really big, and you would have to subtract 360 and then try to figure out where that angle is or something, right? On your test, it's not that difficult, I guess, if you want to say that's difficult. But these types of things, or even like cosecant of t, if t is this, like things like this will be, this will be on there. So know those for practice. And we can go back to them if people want. But I'm going to skip ahead and do number 18, because there is one. I will say there's definitely one like 19, but 18 and 19 are very similar. So if you want more practice after we do 18, try number 19 and see if you can get it right. But let's check it out. So for 18,
I'm sorry. Do you want to do part E from number?
Did I skip? Oh my God, did I skip a part on this? Oh yeah, I totally did. I'm so sorry. So find 2 other angles. And I don't remember if part E is on the test or not, because I know it's not 5 parts, but I really don't remember which ones we picked. So, okay, so find 2 other angles, a positive and a negative, that are coterminal. This just means if it's in radians, keep adding and subtracting 2 pi until you get a positive angle and a negative angle, right? That's all you have to do. And if it's in degrees, keep adding or subtracting 360. So to start, I can take, for part E, I can take negative 7 pi over 4 and subtract 2 pi. And I'll get another negative angle. And there's my negative coterminal angle, right? So, but remember, 2 pi is the same thing as negative 8 pi over 4. So this ends up being negative 15 pi over 4, okay? And I would try to keep it as a fraction. You can use your calculator for this. Just ignore the pi's and do negative 7/4 minus 2, right? So that's negative 15 pi over 4. So there's a negative angle. And then for the positive one, we would do negative 7 pi over 4 plus 2 pi. So that's plus 8 pi over 4. And that's going to be just pi over 4. That gets us back to our reference angle, right? Now, suppose it was still negative. Suppose it was negative pi over 4 and we still weren't there. Just add 2 pi again until it's positive. Okay. And that's all you have to do. And those are coterminal. Because it's basically just saying I'm going around a next time and then going back to the same angle, or I'm going the opposite direction and I'm getting the same terminal. Like coterminal means if you draw the angle like the way that we did here, the terminal side, ooh, you can't really see that. Oh, let's do green maybe. The terminal side is, and maybe I should only highlight, is this side right here. So when it ends there, it's coterminal, and you could do infinitely many parts of this. And thank you, Veronica, for pointing, and Michael for telling me, hey, you missed part E. Like, what are you doing?
Do you want us to, when we answer this, put it in radians or degrees, or will either way it?
Okay, so this is a really good question. If the problem is in radians, give me an answer in radians. If this said T equals, 175 degree, or, whatever it said, then you can give it to me in degrees. Okay.
Thanks.
Yeah, that's a good question. All right, now we'll get to 18, to our nice, lovely triangle here. I sense some right triangle trig, SOHCAHTOA, something like that brewing. So it says to find lengths A, B, Y, and C. Okay, they just label these, right? This total, they give us the total is 15 here. They give us 6 over here. So and they give us 40 degrees. And this is a right triangle. So what I see first, I mean, you can do this actually, there might be multiple ways you could do it, but what I'm going to do first is figure out what A is, because then I can subtract from 15 to get B. Then I can do, Pythagorean theorem or right triangle trig to get Y. And then I can do Pythagorean theorem again, or, to get C, or right triangle trig. So again, there are a few different ways you can do this. And this is why on your test, I want you to just show your work. And if you did it slightly different than the way I'm about to do it, but you got the right answer, cool. Like, I'm not complaining, right? So just keep this in mind, but I'm going to do it this way. And if you do it my way, cool. If not, just make sure you get the same answer. Maybe the decimals will be slightly off. It does say round to the nearest tenth. So I think we should be good, but it might be the case that we're slightly off. Okay. So first, like I said, I'm going to find A using, so this 40 degrees, then this is my hypotenuse, and this is my adjacent. So I think I'd use cosine. So I think I'll do cosine of 40 degrees equals A over 6 centimeters. So A is going to be 6 cosine of 40 degrees, which, let's round this. And I should have had this ready, but I don't. 6 cosine 40. And make sure you're in degree mode. I hope I am, but this is about 4.6. So I'm going to, it was like 596, blah, blah, blah. But I'm just going to round this to 4.6. So now I know that this is 4.6. So really, you could solve for B in another way, but I'm just going to do 15B is 15 minus 4.6. That's the easiest way. And this was A. That's the easiest way to do this, right? Because otherwise, you're kind of doing a little extra work. So that's going to be 10.4. So B is 10.4. And I'm just labeling my picture for myself, but you just need to, make it clear whether you're labeling the picture or writing it again. And this, yes, I can post this to Blackboard. David has asked, will these be, I'll post it tonight. I have to leave right at 7:45 to do something. So it might be at 9 o'clock when I'm back. So I'm sorry, but yes, I will get these posted. Okay, so now I found A, I found B. Now I want to find, I'll do Y next. So you have 2 options here. You could do Pythagorean theorem and do 4.6 squared plus y squared equals 6 squared, or you could do 40 degrees, y, and 6, and you could do sine, right? I don't really care which one. I think I'm going to do sine, but I think typically Pythagorean theorem might be like easier for most students. So let's see if we got the same thing if you did Pythagorean theorem. So I'm going to say sine of 40 is going to equal y over 6. So y equals 6 sine of 40 degrees. And this is about, let me just check, 6 sine 40. 3.856. So well, if I'm rounding, it's like 3.9. Now, if you did Pythagorean theorem and you get like 3.8 because it rounded differently, that's cool. Like, I'm not going to be mad about it, right? Because if you showed your work, I would see, oh, you did Pythagorean theorem, you got an answer really close to mine, good to go. The issue would be is if you got 5, that's not close to 3.8 or 3.9, right? Or if you got 2 or something, right? Okay, so there's my y. Now let's get my c. So now I'm definitely going to do Pythagorean theorem here, saving the best for last. So I'd have 10.4 squared plus 3.9 squared equals c squared. And again, I'm using my rounded values. Oh, and yes, somebody said, could you also do tangent 30? You mean 40? I think you mean 40, but yeah, tangent 30. Are you looking at the next problem or? So German said tangent 30 is y minus or y over 10.4. Is that what you're? I'm not entirely sure. Where are you getting 30 though? If you're thinking that this is 30, assuming the other trial is 30, 60, 90. Yeah, so you're assuming that. I don't know that that's true. If you got the right answer, then I guess we can assume that, yes. But I actually, for this problem, I actually do not know if that is totally true. Because this the triangle on the left-hand side, this isn't even like 45, 45, 90. It's a 40, 50, 90, so it's something kind of random. So I'm not going to assume that this one is 30, 60, 90. But we could see if you got the same answer. So I'm going to do it this way. So then I'm going to enter, what do I got? 10.4 squared, then plus 3.9 squared. So this is 123.37 equals c squared. I take the square root of 123.37 and I get 11. So C is about 11.1. It's like 107, but we'll round, and I got 11.1. And these are all technically centimeters. I'm not going to take points off if you don't label, but if people are wondering, they're technically centimeters, right? Because we started in centimeters. Okay, so I've done these. Okay, let's see, 22. So again, number 19 is very similar, and this is a 30, 60, 90, right? These are. So I can't say that your test is that, but I know that something like 18 and 19, some morph of these, very similar to your test. So, if you're good with that, you've got 1 out of 11, okay. I'm going to skip ahead now to 22. I'm going to do 22 and 23, except 23, I don't think I'm going to do, or no, we'll do, I won't graph every single one because it's like A, B, C, D, E, but you'll get the picture. I'll pick a few. And 22, we can do this. So sine of t, they give you √7/5. Evaluate the indicated functions. Okay, this is what I was talking about where I will not give you this. You need to remember, is sine even or odd? And what's going on here? Like what you need to remember, is it periodic with 2 pi or pi or what's going on, right? So, I mean, clearly they kind of are going to tell you because like you just have to remember if the negative, what you have to remember is this equal to negative sine t or is it equal to positive sine t, right? But keep in mind, there are only two even functions. They are what? Cosine
Cosine, secant.
and secant, right? And secant's related to cosine, hence why they're both even. So these functions, cosine and secant, cosine of negative theta or t, maybe I'll stick to t, sorry. Cosine of negative t equals cosine of t because they're even. Same thing with secant. Secant negative t equals secant positive t. Every single other function, if you throw this negative in there, the negative's got to come out front as well, which, okay, I shouldn't have written it there. But so for sine, that's how I know this has to be, oh, what happened? This has to be true, right? Because sine is odd, okay? So it's just not one of the even ones. So this isn't, I'm not asking too much to memorize that. And I have sine is like, so this is just negative square root of 7 over 5. I didn't even have to do Pythagorean theorem. I didn't even have to think about it. I just know, oh, it's odd, put the negative in front, boom, done. But now sine of t plus 2 pi. Again, sine and cosine, actually everything except for tangent and cotangent has a period of 2 pi. For tangent and cotangent, it's pi over 2, right? Or something like this, right? And if you think of if you can remember the graph or think of like, where is it undefined or whatever, that helps. But yeah, sine and cosine and everything related to it, they have a period of 2 pi. So if this is plus 2 pi, if it was sine t minus 2 pi, if it was whatever, they're the same. They're the same thing as sine of t, right? So that means, again, I didn't have to do any work and it's the square root of 7 over 5. So far I'm liking this problem and I really do hope it's on the test. And don't stress about these. Like I see these problems and sometimes I think, I don't know what the heck to do, but then you just got to remember, oh, even and odd functions. It's not that crazy, right? And so cosecant of negative. So remember, these are even functions, even. Everything else odd. So cosecant is also odd. So this equals cosecant of t. And cosecant is 1 over sine. So how sweet is that? We can just reciprocate this. So we've got 5 over square root of 7. Okay, yes, you have to rationalize, but not going to kill you. So we're going to do 5 root 7 over 7, right? And again, I thought I was going to have to do Pythagorean theorem on this one, and I did not. So that was a happy day for me.
I think shouldn't that be negative?
Oh my gosh, you're so right. I messed this up, right? This is negative. Yeah, I was thinking even, but yes, good catch. Let me attempt to just fix this, right? Right, these were the even ones, and remember, odd, that negative sign stays there. So this negative stays there, this negative stays there. My bad. So thank you so much. And then the negative is in my answer. Yeah. Whew. All right. But it is easy to make this mistake, right? So if you did show that work and I saw like you got A right, and then you like missed it on C, I'd be like, you weren't thinking like, okay, minus like half a point, or something like that. But if you got the whole thing wrong, I would know you just did not remember if it was even or odd, right? Okay, so that's 22. Now we're going to look at the graph stuff. So 23, and I think I picked one at the end as well. Okay, for the graphing, it says identify intercepts, asymptotes. Okay, we didn't really talk about holes, so that's not going to be on there, but that is in your book, and it was on the so if it's even, yeah, it's not even for sine, so that was my bad. So thank you, so Joseph, for your question, and thank you, Michael, for clarifying that. Yeah, my bad. Okay, so again, I'm not going to graph each of these, but actually the first A, B, and C were in your homework. So if you guys did this homework, and maybe that's why I picked this, if you did this homework, it looked, so for A, maybe I'll just kind of sketch what each of these kind of looked like. For A, you had to sketch a horizontal asymptote and you had 2 vertical asymptotes. Hold on. All right, my dogs sounded like they were chewing wood, but let's just hope they're biting each other instead. Okay, So you had to draw, and again, I mean, those asymptotes, the way, if you want to know, so VA is when denominator equals 0, like after you simplify. HA has those cases, so is based on like the degree of the numerator and the degree of the denominator. So for example, if the degrees are equal, it's those leading coefficients, right? If the degrees are, if it's smaller on the numerator, then it's just y equals 0, which is why in this first one, it's y equals 0. Then they're equal here, so it's 3/1, so it's just 3. Then this one is bigger and this one is smaller, so there's no horizontal asymptote here. So keep this in mind. And I remember, I don't know if I mentioned this last class, but I remember someone saying, oh, it's y equals 1. There's like a case where it's y equals 1. It was when the degree, like m equals n plus 1 or something, right? Degree of the bottom is 1 higher than the degree in the top or something. And when that is the case, you end up, it was like you have a horizontal asymptote of y equals 1. That was like a very special case, and that was taught specifically for those types of problems. So we're going back to, we're thinking more generally. So just think, if they're equal, I look at the coefficients, kind of like in part B. If the degree on top is less than the degree on the bottom, like in part A, then it's just y equals 0, right? And if the degree on the top is more, there's no HA, there's no horizontal, right? So just keep that in mind. But then what I would do, if you split it up like this right here, we've split up into like 3 zones, right? I see 3 zones here. And in each of those zones, you want to plot at least 1, maybe 2 points to figure out what's going on. And you want to check to see if it crosses the HA, if there is one. So in this case, to do that, to cross the horizontal asymptote, it has to equal. So in this case, there's an HA at y equals 0. So P of X would have to equal 0. So can P of X equal 0 for some X? And in this case, that means 6 would have to equal 0. And that can never happen, right? So for this, it's not going to cross. And so when you plot points, you get like a point down here, which means it's going to approach, it's going to never cross, and it's going to approach these here. Then when you plot a point over beyond, you get like something here, and there's like a curve, and then you'll plot and get a curve over here as well. And somebody asked, can I find the signs with graphing in tests? I'm assuming you're talking about the signs, like if you do a little line graph and you get the sign of the function, you could do that, but it's not
No,
necessary.
I'm talking about the Desmos or graphing calculator, putting the.
Okay.
functions
So yeah, so for this
looking
one,
at-
yeah, so for this one, you actually are, I mean, you guys are allowed calculators, right? So you could even graph this, but you just have to clearly show these, whatever it's asking for. And so you could graph it, and that, to plot some points or figure this out. So it is kind of silly, but you need to also get the graph right, so yeah, so you can definitely find the signs with graphing. Like if you plot this and then go to the table or something and get a few points, you can do that. Yeah.
I'm very sorry, but could you please explain A for me again? I was just having a hard time following.
Yeah, let me redo it. Here, hold on. I have to just create one of my dogs because they're being crazy. Hey. Almost done. Okay. All right, sorry. So let's do part A here. So review graphing. I don't know. Okay. So it was P of X or something equals 6 over X squared minus 9, right? So first, and Miranda, if there's a specific part, let me know, but I'll just kind of start from the beginning. So VA is going to happen when X squared minus 9 equals 0, which I know this is X plus 3 and x minus 3, right? So I'm going to have a VA at x equals 3 and x equals -3, because it's whenever the denominator like is 0. That's how we get the vertical asymptote, okay? Then we want to find HA. So HA, I look at the degree in the numerator, and it's 0, because this is just nothing. There's no x, right? It's x to the 0. And this is less than the degree in the denominator, which is 2, right? So 0 less than 2. And because it's less, I just know there's an HA at y equals 0. Okay? So that's kind of how I start this problem. And so from there, I have these things, right? And I know it does not cross the HA, because P of X can never equal 0. Like, and if it was y equals, if it was 5, I would have to test and see, could it equal 5? And P of X cannot be 0, because in order for this function to be 0, the numerator would have to equal 0. Like, you can only get 0 by doing 0 divided by some number. And 6 is just 6. It's always 6. It's never going to change, right? So it's not going to cross. So this is good information for me to know. So now I can say, here's my horizontal asymptote. Maybe I should have kind of drawn some lines on here. Okay, and say I go by ones, right? So I know I have vertical asymptotes at 3 and -3. And now you can use, because you're allowed a calculator, this is what I recommend you do to also save time on the test. I recommend you use your calculator, and based on looking at this, you plug in values. So like, I would plug in a value that's in this range, so that I like from -3 to 3, an X value, then plug in a value from over here, then a value from over here, right? So let's pick those values. Okay. So I'm gonna pick Z. Oh, whoop, that's not what I wanted. I'm gonna pick 0 for X. Then I'm gonna pick like -4 and +4. And maybe you need a few other points, but I'm just gonna pick these and we'll go from there, right? So to start, I'm gonna get, if I plug in 0, I get 6 over -9, which is the same as like -2/3. Okay, which you could get the decimal if you wanted. This is fine. Then -4, I'd get, 16 minus 9 is 6 over, so I'd get 7, right? Or I'd get 6 over 7. And then same thing here, I get 6 over 7. So, okay. Now I plot these and I get 0, -2/3. So, and I know it does not cross the HA. So there's a point here. I just know it has to approach the other asymptotes. It's always going to approach, I'm so sorry for my dog. It's always going to approach an asymptote, right? So if the point was up here, I know it would go this way, right? But it was below. Now I have 4 and -4, and it's 6/7, which is like almost 1. So, I mean, okay, my graph's not perfect here, but at 4, it's almost 1, and at -4, it's almost 1. I also know, and this is so not perfect, like yours, I mean, some will look better than others, but it's something like this, right? Did that help maybe in answering your question, or?
Yeah, it was better for the breakdown portion of it. I was able to see it a lot better visually. I
Okay,
think
so I'll do this for the other, I'll do this for the others. And
Oh,
maybe
yeah,
I'll do this for all the ones that were on the homework, because a lot of you guys did do it correctly or you got it, but maybe going over it will just help. So that was part A.
Can I just mention
yeah,
that
Michael, go ahead.
the X and Y intercepts, there is no extra intercepts.
Oh,
The
I didn't,
Y-intercept-
yes.
The
Yeah,
Y-intercept
okay,
is
so
0, the point is 0, -2/3.
yeah, so good. So it did ask for intercepts, right? It said like plot the intercepts, Well, and so if you're tracking that, so thank you, Michael. In this case, because it doesn't cross the horizontal asymptote, it doesn't go over that, there's no x-intercepts here because it never crosses. So there's none. And then for the y, it's just plug in 0. It was 0, -2/3. So the y-intercept was 0, -2/3, right? So the question did, I guess, ask like plot the intercepts. Well, in this case, there was only a y-intercept. Yeah, good call. And then next we'll look at an example where it does cross the asymptote. So that was in B. So if we have, oh yeah, go ahead.
Are you going to want us to draw out the graph on the test like you did?
Yeah, so I think there's only one where there's actual graphing, and I put a graph on there, but if you have to sketch it yourself, literally, I mean, you saw me do it, right? Something as not that this is simple, but I'm saying simple, something as simple as this, even if it's a little bit more like, difficult or like not as perfect, not that mine is perfect at all, that is totally fine. So I would recommend maybe going through some of these tonight or tomorrow when you're studying, and just, if you're going to write it on paper, practice graphing a few of them. And like, I mean, really the most important thing is sketch your asymptotes, right? Your horizontal and your vertical asymptotes, like that's important. And then plot a few points, right? And if you're worried, like this doesn't look great, if you give me this table on the side too, to show me like, hey, these are the points I plotted, I'm not going to be picky. Like, it does not have to look perfect. Okay. And again, there's only one actual like big graphing. Well, if there is a second, it's not going to be, yeah, I think there was only one that like you actually have to graph something like this, right? But yeah, so you should be able to do this just on your paper, or even if you have graph paper or something and you want to just like have that handy and put it next to your work, like that's, you could write on graph paper. That's also fine. But yeah. Okay, now I want to look at just what this was. This next one, and it was called G of X. Oops. Okay. Okay, so it was G of
That
X.
was a little bit more involved, I think.
Yeah, this next one. Yeah, is it the 3x squared minus 5x minus 2
yeah.
all over, okay, x squared plus 1. Okay, so looking at this one, this can never equal 0, because if I solve it, I get x squared as -1. That's imaginary. So what this means is there's no vertical asymptote. So this is already going to be a little weird. Hey, Kobe, come here. So this is already going to be a little bit weird, but that's fine. There's no vertical asymptote. Then for horizontal, for HA, the degree is the same. So the degree in the numerator equals the degree in the denominator, right? And therefore, it's going to be 3 over 1. So y equals 3 is our HA. And if we want to say, does it cross? We'd have to say, can g of x equal 3 for some value x? So let's solve for this. So this is more involved. Actually, maybe this is what Michael was talking about. You do have to say, okay, 3x squared minus 5x minus 2 over x squared plus 1. Can this equal 3? Maybe I should have done this. Can this equal 3? And so to do that, I need to solve this. So to solve this involves just a bit of algebra, right? So I multiply both sides by my denominator, and then I get 3x squared minus 5x minus 2 equals, and I'm going to distribute this 3x squared plus 3. Then I move things around. I'm going to put all my x's on one side, all my numbers on the other. So I'm going to say minus 3x squared I'll keep, I'll keep the 5x, but I'll do +2 +2. And then these cancel. Oh, they both cancel. Actually, that's kind of nice. I get -5x equals 5. So x is -1. This works. So this means that -1, 3 is a point on our graph. So yes, does it cross? Yes, it does. Okay. So now I want to look, are there any intercepts? Well, and this is also where maybe it's a little tricky. So if I look for intercepts, well, the y-intercept, that's just plug in 0 for x, right? So y-intercept is going to be 0, -2. Or, oh, yeah. And then for the x-intercepts, this only happens when the numerator equals 0. So this here has to equal 0. And you could mess around and potentially try to factor that. I'm not sure. Like, I mean, you could say, okay, 3x minus 1x minus 2. Does that?
Yes.
That does work.
+1.
+1. Okay. Oh, how nice. Okay, so this does work. So factoring works, but if you do not know factoring, you could always do the quadratic formula here. If you're stuck, you could always just, graph this and like look for it, right? But okay, so this is good. So we're gonna get x is -1/3, and then x is 2. So my x-intercepts are -1/3, 0, and 2, 0. Okay, so now I have a lot of information. Now I have my, I have a point where it crosses. I have a horizontal asymptote, no vertical asymptotes. I have x-intercepts. I have y-intercept. So now I'm going to go to the graph and I'm going to say, okay, I'm going to do this and kind of just maybe put like 5 or 6 tick marks to see if that gets me enough for now. And again, these are not perfectly evenly spaced. This is how you can do it. Like, if you have the ability to do it neater, great. But this is perfectly fine. So I want to plot all these points that I have now, right? This is just 1, 2. Okay. So first I'm going to do my asymptote. So y equals 3 is my horizontal. And remember, it crosses at -1, 3. So there's a point right there. Perfectly fine. Then I have -1/3, 0. Maybe that's there. Then I have 2, 0. That's there. Then I have 0, -2. All right, something weird's going on there. And if you're like, okay, I don't know what the heck this is going to look like. So if you're thinking, one, you can put this in your graphing calculator and then try to sketch it from here. Where there'll always be a cross point. Joseph asked a question. No, Joseph. So remember in the previous example, I apologize for scrolling, but this example never crossed the horizontal asymptote because the numerator could never equal 0. So it will not always cross that. But this is just an example where it does. Now I looked at this and I had no idea. I'm like, all right, I can guess how this might look, but I did not know. So I went in my calculator and I just, go to the pen. And I just made a little XY table and I had found out, okay, what is Y when X is 1? How about, I think I did like -2 and -3 or -3 and -4, something like that. And I found these Y values, right? This is unnecessary. Like you don't need to do this, but it helped me visualize better just what's going on and what's actually happening here, because I'm like, okay, clearly I know that it has to approach my asymptote in some way. And I can clearly see that I go down and then I like swoop back up somehow. And then, okay, maybe I'm approaching this asymptote. I got that part. But like, what the heck goes on here? Like, does it just go up like that? That's
right.
Like that's what I first thought. Like, I'm like, even me, right? Even your professor. I'm like, wait, something fishy's going on here. But when I plugged in these points, and maybe it was -4 as well, I can't remember. But when I substituted these in, I realized, oh, it goes up a minute, but it actually goes back down and it gets really close to 3. Like it just keeps getting like decimals closer to 3. They're like 3.1, 3 or 3.2, And so it does, and again, my graph right here, actually, some of you guys did a better job than me drawing this curve. And kudos, but like this is also acceptable, right? So if you can just get these main points that I was able to get here, that is the goal, right? That is the goal. Yeah. And this was a very involved one. I think the next one is involved, but it only because of the slant asymptote, which actually maybe is not as bad as maybe this one. But let's see. So now if I have like f of x equals x squared plus 7x plus 10 over x plus 3. Okay, now we want to graph this. So first, my VA, I already know is at x equals -3. Good to go. Now for my HA, 2 is bigger than 1. So for HA, 2 is bigger than 1, which is my degree in the top, degree in the bottom. So no HA, but slant, we're going to have a slant. We're going to have a slant asymptote. And I know that because I think this is the case where, you know, we had m is n plus 1 or n is m plus 1, one of these, right? So we're going to have to divide and figure this out. So when I do my long division here, I'm going to have x plus 3, x squared plus 7x plus 10. I'll do this maybe too quickly, but I know I can multiply by x and then subtract it. Yeah.
Why are we looking for a crossing point?
In the previous?
Yeah, I mean, no, generally.
In general, we only look for it so that we know, does it cross or not? Because we have to graph it, right? And it helps to know, is it going to cross? Because if it's not, then we know, like in this first one, because I knew it wasn't going to cross, when I plotted a point here, here, and here, I knew it has to approach the asymptotes without crossing.
So it's only necessary without calculation.
Yeah, you don't need to, like, when I write this out, that's not necessary, but it for you to like write, if you didn't write does not cross, I'm not going to take points off. But if you graph it wrong and you don't write it, I'm going to take those points off, because like, let's say you graphed it and you had, you know, this cross and it just went down this way or something and then up this way, like that would be not right, you know? So that, just keep that in mind, but I'm not taking points off if you're not telling me like this didn't cross or whatever.
Okay.
Yeah, it's more so to help us figure out what does the graph look like. Because otherwise, you know, it might be like this one was very tricky, the last one. And so now here I'm just doing long division. And again, you could do synthetic if you wanted, right? There's people like this, we found out. But I get something like this, and I'm going to say plus 4. So I get 4x plus 12, and I subtract, and I get -2. Okay, so x plus 4. So my slant asymptote is at y equals x plus 4. Okay. So now I know my vertical asymptote, my slant asymptote, and I want to get, are there any intercepts? So let's see intercepts. So f of 0 is going to just be 10 over 3. You could leave it like that, or you could write it as, what is that, 3.33 repeating, right? Doesn't matter. I don't really care. So this is the y-intercept, 0, 3.33. Then for the x, you would need this to equal 0, the numerator. So this was y-intercept. And this is the same thing as x plus 5 and x plus 2. We can factor this pretty easily, right? And so x is -5 and x is -2. So my x-intercepts, I got, there's 2, and it's -5, 0, and -2, 0. So I'm starting to get a good picture of what this is going to look like. So I know. Okay. So I know that my vertical asymptote -3, right? To get your slant, I would just plot a few points. So like y equals x plus 4. I can do 0, 4. So 0, 4. Then I can do, -1, 3, maybe -2, 2. And then I can just kind of cross that. I know it's going to be something like this. And then I have my x-intercepts to plot, which were -5, 0, 1, 2, 3, 4, 5, and -2, 0. And in this case, I mean, you can definitely plot more points, but in this case, I know it's a slant asymptote. It's approaching the asymptote. It's not gonna cross that. So I know it's something like this, and something like that, and that, right? I just know they're gonna approach my asymptotes here, and this will be the graph. Yeah, this graph looks really strange, for sure.
Oh, the next one. Anyway, looks like there's a question.
Yeah, sorry. Will the slant be on the exam? I'm not gonna say for sure, but I think there might be one slant. I don't remember if it's a graphing, but I know that there might just be a question asking you to find the slant. So definitely try another one of these when you're studying. Somebody said, when does checking even or odd come in? In this case, you don't have to check even or odd. That's with trig. So checking even and odd was when we had to do like sine of -t, and they gave you sine. You have to know that that's negative sine of t or cosine of -t, and this is positive cosine of t. That's the even and odd. That's when we did that.
Can you, when you just look at this problem and see that on the bottom, it's just x plus 3 and not x squared, is that kind of a giveaway too, that it's a slant?
Yes. So you will, if you have a slant asymptote, you will only have a simple denominator, like x plus 5 or x minus 1 or something like that. And that's the giveaway that, okay, here I have a slant asymptote. Yeah.
Okay.
And then Michael, did you have a question?
No, it's just, I don't think we're going to have time for a bit.
I know. Yeah, I'm
on
realizing.
letter D, one of the things, that one was really interesting because it has a slant of x minus 2, but then it also has an x-intercept of 2, 0. So I couldn't figure out and I think it crosses the slant asymptote.
So okay, what I will say about part D is that this problem, it has see how in the denominator it's a quadratic. This is why.
Okay.
It's a cubic over a quadratic. You will not see that on the test. It will, on the test, like I said, it will be simpler. So these homework problems and these book problems, a lot of them are exponentially more difficult than what you're going to see on the exam.
Mhm.
So definitely don't overthink when you're taking the exam, right? But
Right.
they are harder. So definitely like if you can do something like that, I mean, awesome. Like the exam, well, hopefully it's like easier, but focus more so on what we've done and what, and look at your notes. So I would also say what's in the notes, study those problems too, because I know the notes sometimes notes problems are taken and rewritten for exams. And again, some of these problems that I picked today, they are like those word problems at the beginning, they are very close to what is on the exam. But yeah, I would say something like part D is not going to happen. You're not going to.
Yeah, that one was really
even E. Yeah, you're not going to have a hole. Like we didn't do any graphs with holes, so you're not going to have that.
Okay, that's cool.
Oh, and sorry, there's another question. Not sure what that is asking either. Do you mean on the graphs where it's asking? Oh, yeah, I don't, or if he's I'm not sure what he's talking about. And then the last one, you can email me whenever. So Joseph is asking when, again, I do have to go somewhere just briefly tonight after this, but then I'll be home, and tomorrow I should be checking my email all day. So you can email me about the review whenever you want, and I'll respond as soon as I can. I think the last thing I wanted to say that I didn't go over today, but we have done these types of things, was number 27. So there is a problem like solving the inequality. right? And so for this, again, I mean, I think there's nothing as complicated maybe as B, but maybe try A, right? And you give your solution like, oh, maybe the solution is -infinity to 5 and you include 5 or something like that. I mean, that's not the answer, but that's like how you might write it, right? So go through, we did some of these in the notes as well. And also think about, I don't remember if it's specifically domain here, but looking at like, what's the domain, or actually it's not even that complicated, but it might be something like these, where it's a square root and you'd say, oh, well, 9 minus x squared, it has to be greater than or equal to 0. So then I solve that. These are actually more difficult though, so don't be overwhelmed by these, because these are more difficult than what is on your test. So I would recommend for something like 29, look back at the notes and maybe other homework, other book problems and simpler ones. And that's what you'll see on the test. And maybe, Jermon, maybe you were asking something like about this. Well, if we want, so solve the inequality, if you want f of x less than or equal to 0, you just look at when it's equal to 0 at these numbers, and then we want less. So we want these. So this would be like -infinity to -2, union 0 to 3, right? You're looking at specifically when it's negative. Here, it's when it's less than 0, but not including these values. So all of this, not including 3 here, right? So this would be something like 0 to 3, but we can't include those because it's 0 and we don't want equal to there. And then it would be 3 to infinity. I actually don't know if we put any of those on the test. I don't think we did because I didn't pick it. But if we did, this is what you're doing. Don't overthink it, right? And I'm so sorry it's overtime, but hopefully that did answer most of your questions. And please send me an email or get together. There's a group meet or whatever the heck that thing is, and get together, study together, solve problems, whatever you got to do. And we will be here, meet on Thursday for your test.
Awesome.
Yeah. Thank you guys. And
What
yes,
about, what about multiplying by the conjugate or whatever?
That's not on the test. I will send, I'm going to retake the test tomorrow morning. If there's anything funky or whatever, and there's no time for me to change it, I'll send a little Blackboard reminder to the class, like, hey, take a look at this problem here, like just to help you. But I don't think there's going to be anything like that.
Okay.
Yeah.
So as far as like display goes of the exam, you said that you're going to post the exam to Blackboard and we have to either print it out or use an iPad?
No, or write on paper. You can also write on paper.
Okay.
So however you did the quiz, so if you're one of those people and you just had regular paper and a pencil and you wrote all the questions, you don't even have to rewrite the question. Just number 1, your work and your answer. Number 2, work and your answer. And then either scan it using that app on your phone, go to the group meet, people like talked about it, or take a picture, email yourself the picture, and then like save it as a file and upload that to Blackboard. Does that make sense?
Yeah, I just don't really understand how
Recording stopped.
going to be on the Zoom, and how are we going to view the answers if
view the test, you mean? You're gonna be on Zoom.
Yeah.
You'll be on Zoom and then you'll log into Blackboard.
One thing that I've done in the past is that you use your Zoom on your phone. So, and then use your phone to view yourself, and then use your computer without Zoom, and you have Zoom on your phone.
So you can do this. Yeah. So Michael, thank you. So McKenna, if you'd rather use your phone, set up your phone like, this way on Zoom, have it be looking and like, me see your desk and I'm standing, and you're writing here, right? And then your computer can be in front of you and you're opening it up on Blackboard. And I would see you open it But if you're on your computer like the whole time, like Googling answers, I need to be able to see you, and I'm recording, and that'll be like the cheating suspicious, right? But yeah, if you have your phone and you set it up somewhere over here, and then your computer is here, you can also do that. But even if your computer's in front of you, and like if this was me and I was taking it right now, I mean, I would maybe move my computer like this, but I would just have Zoom in the background, and I would go onto I have like Google Chrome open or whatever on Blackboard. I would click on the test, and I would just see myself looking at the computer every once in a while, and I would just be scrolling through it. So you have options here. Don't think like you have to do one or the other.
Okay.
And email me if you're like worried or have a question. Okay.
Thank you.
Yeah. Okay. All right. Hopefully everyone else is feeling good. Contact each other in the group me. And I'm so sorry. I do have to go, but have a great night, everybody. Okay.
Thank you. You too.
I'll see you Thursday.
You Thursday.
Actually, before you go, I got a quick question.
Yeah.
So this Thursday, I'm going to be flying to New York City.
Oh.
And hopefully I should be booked and in my hotel by the time by your class, right?
Yeah.